Hello and welcome back. This video is about multiplication rules in statistics. In this video, we're going to cover the multiplication rule, which looks different but is an old friend, and the special multiplication rule that applies to independent events only. So let's start with the general multiplication rule. We read the formula as the probability of A and B happening together is equivalent to the probability of A times that conditional probability of B given A. This may look like a very different rule or new, but if we recall the formula for conditional probability, it's actually the same thing. So what we can do is if we multiply each side by the probability of A, these cancel out or equal 1, and we're left with the formula. So it's not necessarily something new, just a twist on something old. So now that we've introduced the general multiplication rule, let's put it into practice. So in this example, we're given a word problem with a lot in it. And with word problems, it's often easy to get overwhelmed. So my tip is to read the question first. This gives us an idea of what we're looking for as we go through. So let's read that question. What is the probability that a randomly selected Ziduian will be a unicorn and like chocolate? Now let's read through the question and pull out things about unicorns and liking chocolate. So Planet Janet has established friendly relations with Planet Zidu. Zidu is the home of the galaxy's largest intergalactic hub. This isn't very important, such as the planet's population, Dragons, okay, Ligers. Okay, 18.7% of the population of planet Zidu are unicorns. That's good to know. And the remaining don't care, that's not important. And so then we're going through and reading about chocolate, and 53% of the unicorns like chocolate. All right, now we've pulled it out. Now that we've gone through and highlighted the information, it makes it a little easier to figure out what we need to do. So we need to find the probability that a randomly selected Ziduian will be a unicorn and like chocolate. So let's recall our formula. So the probability that they'll be a unicorn and like chocolate, we know that that's equal to the probability that it's a unicorn times the probability that they like chocolate given that they're a unicorn. So I like to make reference boxes. So 18.7% of the planet of the population are unicorns. So 18.7, and that's our probability for unicorns. And we need to change this percent to a decimal. So we just move the decimal places 2 places to the left or divide by 100, whichever makes more sense. So we're left with 1.187, 0.187. Now what's our conditional probability that we're looking for? The condition is that they like chocolate given that they're a unicorn. And that probability of C given U is 53%. And again, we're going to change that into a decimal, moving it over 2 places to the left to 0.53. Now we have all the pieces of our information to figure this out. So the probability that a randomly selected Ziduian will be a unicorn and like chocolate is computed by multiplying 0.187 times 0.53. And when we put this all into our calculator, we get 0.099. And we need to change this back into a percent. And so we move the decimal places 2 places to the right or multiply by 100, giving us a 9.9%. Now it's time for the special multiplication rule. There is a caveat or condition with these multiplication rules. Events must be independent. And we'll have another video about independent events and how we define it. But a good rule of thumb is that if we have 2 events knowing the outcome of the second does not affect the outcome of the first. And oftentimes we use examples like dice and coins, because if we flip a coin, the odds of getting heads or tails for the second coin is exactly the same. So if we were rolling 2 dice, what's the probability that we get a 4 and then a 3? So the probability of getting a 4 and 3 at the same time is computed by multiplying the probability of getting a 4 times the probability of getting a 3. Now for fair dice, the probability for each is 1 over 6. So the probability of getting a 4 and 3 when we roll 2 dice is 1 out of 36. Another example is coins, where we have heads and tails. Now the probability of getting a head is 1/2. The probability of getting a tail is 1/2, assuming that the coin is fair and not weighted. So let's compute the probability for getting tails, heads, tails. The probability of tails is 1/2 times the probability of heads times the probability of tails. And we multiply all these together to get a probability of 1 over 8. Or on average, we should see if we flip a coin 3 times, 1 out of 8 times we'll get the pattern tails, heads, tails. This version of the special multiplication rule just tells us that this can be used for a lot of different events happening at the same time. So if we were to say we want to roll a dice 6 times, and we get a 1 the first time, a 2 the second time, a 3, then a 4, then a 5, then a 6. So assuming that the dice is a fair dice, the probability of getting 1 on the first roll is 1 out of 6, times the probability of getting 2 on the second roll is 1 out of 6, 3 on the third roll, 1 out of 6, 4 on the fourth roll, 1 out of 6, 5 on the fifth roll, 1 out of 6, and 6 on the sixth roll is 1 over 6. And this, because we're multiplying everything together, it's going to be 1 over 6 to the 6th power, or it is 1 over 46,656 rolls. And this rule can be used as long as the events are independent. And sometimes for homework, we have to go through and prove that they're independent. And so we'll talk about that more in the independence video. All right, let's do a quick review. We started with the general multiplication rule, which is the probability of A and B happening at the same time. And we compute that by multiplying the probability of A times the conditional probability of B given A. And sometimes you might get word problems for these. Try reading the question before skimming through. It helps to kind of hone your focus and sift through the information to see what's relevant and what's not. Next, we covered the multiplication rule, and this is when we want the probability of things happening at the same time, but they're independent events, meaning that they don't influence each other. We take the probability of A and multiply it by the probability of B. And the last formula we covered is just kind of an expansion. And this says that if we have multiple events and they're all independent of each other, to find the probability of that event, we multiply the probability of each event. Hope this helps. Have a great day.